Hi, today we will be solving Leetcode problem 506 relative ranks. So, what's this problem all about? It says you're given an integer array score of size n where score I is the score of ith athlete in a competition. So that means there is a competition and you are given the scores of the athletes in form of array and there are total n athletes. Okay, and all the scores of athlete are unique. Okay, that's also a point to notice. The athletes are placed based on their scores, where first place athlete has highest score, second place has second highest, and so on. Common sense, right? The placement of each athlete determine their rank. First athlete is gold medal, second is silver, third is bronze, fourth is just fourth, fifth is just fifth, sixth is just fifth, sixth, and so on. You got it? Like first is gold, second is silver, third is bronze, and rest are the same as their places. Fourth is fourth, fifth is fifth, sixth is sixth. Okay. So now what do we have to do? We have to return an array answer of size n where answer I is the rank of athlete I. So what does it mean? You will be given an array of of scores of athletes. Let's say this is athlete one, this is athlete second, this is athlete third, this is athlete fourth, this is athlete fifth. So now we have to tell what are their ranks. So in this case, the rank of fifth, let's see. In this case, it's clear. The rank of fifth will be first, gold medal. The rank of fourth, score four, that means athlete second will be silver. It's three, it will be bronze. And his score is two, so his rank will be fourth. And his will be fifth. Correct. This example was already given, you can say, in the proper sequence. So let's check the another example. Here you will the question will be more clear to you. The scores are 10, 3, 8, 9, and 4. If I try to do their ranking, what will be? Like 10 will come first. The score 10 highest. Second highest score is 9. Third highest score is 8. Fourth highest score is 4. And fifth highest score is 3. So clearly, athlete with score 10 is gold. Okay, the athlete with score 8 is bronze. The athlete with score 9 is silver. The athlete with score 9 is silver. With 8 is bronze. Correct. And 4 and 3 are definitely fourth and fifth. So you have to just give their ranks. Okay. Let me just repeat. You might have got confused. The thing is, we have to see the ranks of them based on their score. 10th will be gold. His score is 3, and what's his rank? His rank is 5th. His score is 8th. What's his rank? 3rd, and 3rd should be done as bronze. His rank is 9. His score is 9th, and his rank is 2nd, and 2nd should be written as silver. His score is 4th, and 4th rank is also 4th, so his rank should be written as 4th. So that's the answer that we have to return. Okay. The placements are simply here: 1, 5th, 3rd, 2nd, and 4th. So first is gold, second is silver, third is bronze. So how can we solve this problem? How can we like while telling you the question, I have told you the most simplest approach. That is, we have to first find the order of their scores. Correct. I have to find which person has come first, which person has come second, which person has come third. For that, I have to check their scores and just sort them. Clearly, this is just the sorted array of the score. Correct. And this is giving me the rank 10th, first, ninth, second, 8th, third, and so on. So, what I have to do, first step will be to sort this array. But if I sort this array, I will forget the position where 10th were earlier present. In this case, it's at same position, index 0. But let's take 9. Here the index of 9 is 1. Here the index of 9 is 3. that will get changed. So instead of sorting score, I will create a copy of the score array and then sort it. Okay. That way I will get the sequence sorted sequence of scores and also preserve the original indexing of my score array. And also you have to sort the array in descending order. Correct. So what's happening? How we are going to do this? What's happening? Like what's the further steps? Okay. So first of all, let's say we have sorted the array. The initial input that was given to us was 10, 3, 8, 9, and 4. 10, 3, 8, 9, and 4. I sorted them. What it becomes? It becomes 9, 10, 9, 8, 4, 3. Okay. So after sorting them, what I will do, I will create a map telling them what their position is. So for 10, I will rotate. I will iterate on this array, this new array, this new sorted array, and I will place their positions. Like I will mention their positions in a map. So in map, let's say it's map for index 10, for key 10, my position is 1. For 9, my position is 2. For 8, my position is 3, and so on. Okay, that way now I have the numbers, the scores, and their positions. Now I have to create my output array, the answer array that I am going to give as output. So what I'll do, I will again iterate over this array, my initial array, and while iterating over this, I will create my output array. So first of all, I will come at 10, and then I will see what's my rank. Is first. If it's first in my array, I will write gold, gold medal. Correct. Then I will come to 3. I will check its rank. For 3, the rank is 5th. So I will enter 5th. Then I will come at 8. I will check what's the rank for 8. It's 3. For 3, I will have to write what? I have to write bronze. Correct. I will come at 9. I will check what's the rank for 9 using my map. The rank is 2. So for 2 rank, what I have to write? I have to write silver. And then for 3, my rank will be 4. Sorry, for what's it? For 4, my rank is 4. Simple, that this will be my output array. So let's see in code how we are doing this. First of all, we are sorting, we are creating a new array. As I told you, we have to create a new array as we don't want to disturb the original indexing, as we have to give the answer in the original format only. For 5 here, like for 10, we have to give the answer at same place. For 3, its answer at same place. At 8, its answer at same place, at same index. So we have to preserve this original indexing also. So for that reason, I'm creating a new array, which is a copy of my given array, and I will sort this array in descending order. Okay. And after sorting this, I will create a map. Which shows- Correct. Here, 10th, the position is 1. So for 10, the position is 1. I plus 1 because index is 0. So I plus 1, 1. 0 plus 1, 1. So for 10, my rank is 1. For 9, my rank is 2. That way, I have created an index. I have created a map of their ranking. Then I will create a vector string as for my output. Okay. I will create a vector string for my output, and then I will go through my score array for their indexes. Correct. And I will check that number. Here my number was 10. What's 10 3? Let's only take the starting 3, 10 3. So 10 3 8. So first I will come at 10. I will check what's the rank for 10. The rank is 1. If it's 1, I will add gold. So for 10, I'll add gold. I've done this previous also above. I'm doing it again for gold. Then for 3, I will check what's the rank for 3. The rank for 3 is 5th, so I will add 5th. Here, as you can see, answer dot pushback to string, the rank. Rank is 5th, then 5th will definitely be under, right? Then for 8th, my rank is bronze. So as you can see, for 8th, my rank is 3. Here we have created the map. Previously, you can see for 8, my rank is 3. So here we have written a condition: if rank is 3, enter bronze medal. This way, our output array will be generated, and we can just give it out. And this is a solution, a good solution. But this solution is working in, like, the complexity is definitely order of n, but there is also a space complexity. Sorry, the time complexity is also not order of n, as we are doing sorting here. So it's n log n. Correct. We are doing sorting. I just forgot about it. Sorry guys. It's n log n, not n. And for size, we are creating an array of order of n. We are also creating a map of order of n. So it's 2n memory size. So we can also do this with another approach. That approach is not something with which is different in terms of stack or time complexity. No, but it's give you a different perspective to the problem. Not the different perspective. I'll say a different way to write the code. Not so much of hectic code. That's by using priority queue. Priority queue. So how can we do this question using priority queue? Correct. So here, what we were doing, we were maintaining the previous index and also maintaining a map for their rank. We were doing these two things. So what we can do while having the array, this 10, 3, 8, 9, let's say, what I can do, I can create a pair of this score with its index. So it's 10, comma 0 a pair, 3, comma 1 a pair, 8, comma 2 a pair, 9, comma 3 a pair. The score and their indexes, and then I can use priority queue to sort them. Okay, I don't even need to use priority queue. I can just use a simple, you can say, array also. But here we are using priority queue and we'll sort them. So what will happen? Everything will get sorted, and I will get my score with their indexes here itself. I don't have to create map. Correct. I will get this values in my priority queue. So when I get this, what I can do, I can just create my output array, and in my output array, at at zeroth index, I will put gold. At third index, I will put silver. At second index, I will put bronze. At first index, I will put three. Sorry, fourth. As these are the ranks, this is my heap sorted. It's first rank, it's second rank, it's third rank, it's fourth rank. So simple. At zeroth index, I will put gold. At third index, I will put silver. At second index, I will put bronze. At first index, I will put fourth. Simple. Okay, as it's fourth rank, so I will put fourth. So let's see how the code works. First of all, we are creating a priority heap. Then we are pushing a pair in this heap of score and index. And then I'm simply creating a vector string, my output of n size. Then at nth place of this output rank array, nth place, I'm putting the rank. Okay, so I'm creating a variable place. So as you can see, first of all, here the place will the rank will be one. Here the rank will be two, three, and so on. So I'm just incrementing it one every time. Okay, so I will creating a place. You can call it rank, but my vector name is also rank, so I have named it place. It's not the different code; it's the exact code from Leetcode. Okay, so I will just do the original index. I will find the original index. What's the original index? It's present in my heap as a pair in second. Okay, it's first. This is called first. This is called second. So in my pair, the second value is my original index. So in output at original index, I will put the rank. If my place is one, then gold. If it's two, then silver. Then third, then bronze, and so on. Two is string. Simple. Okay. I hope you have got this approach also. This approach is also creating a memory stack of order of n, correct. And for output it's also creating, but it's not considered definitely, so it's only order of n. And for what do you say, for for time complexity, here heap is also using n log n. So time complexity here also it's n log n. So clearly there is not much difference between this approach and this approach. It's just the, I'll say, the way you write down the code. But the next approach that we can use in this is, we can somehow try to reduce this n log n into something else. How can we do that? The simplest answer is, if you have till now studied about sortings and many different algorithms of sortings, then you might have come across an algorithm known as counting sort. So what does it say? This is a sorting algorithm that sort of works in order of n, but it can't handle a very large maximum value. Okay, and how it works? Let me just give you a brief of counting sort. Sorry, my pen is not working, so I'm using mouse today. Counting sort. So what happens? Let's say I'm given an array: 10, 9, 2, 5, 1. Okay, and what do you say? 3. So for this, what we do, we create a vector of size 10. Why size 10? Because that's the maximum number present in this array. So we create a vector of size 10, and then we go through this array and mark the numbers which are present. 10 present, 1, 9 present, 1. We come, like, we can directly access this index and mark present. Okay. 2 present, 1, 5 present, 1 present, 3 present. So now, what's my sorted array? My sorted array is simply, if I iterate from here and I will just print every number which is present. So my sorted array becomes 1, 2, 3, 5, 9, and 10. And clearly, this is the sorted array for this array, as you can see. I'm just marking the elements which are present till 10, and I'm just printing them. It becomes my sorted array. Apart from printing, I can also store it somewhere in a vector, and I can say that vector is a sorted vector of this vector. Correct. So this is how sorting counting sort works. So we can use the same counting sort here. Instead of using this, we can use the counting sort here, which will reduce our complexity to, let's see, what's the complexity here? Let's see. We have to iterate through this, which is n size, and we have to also iterate through this, which is some z size, let's say. And what z? Z is the maximum value present here. The maximum value we usually denote by m, so let's not say it's z, let's say m. So we're iterating n times, then also m times. So this time the complexity becomes n plus m. So it has been reduced from n log n to n plus m. And we cannot definitely be sure whether n log n is better or n plus m is better, because it definitely just depends. Because let's say I have an array, let's say 10 to the power 9, 1, 2. If I used n log n, it could have, like, if I use normal sorting algorithm n log n, it could have been so better. But for here, for using counting sort, I will create an array from 1 to 10 to the power 9. Oh, so heavy. So you can't just say कि which one is better, which one is not. So here's the code. It's just a code for finding maximum number. You can just do it. Ignore it. So we will create n is the size, m is the maximum number present in score. We will create a array, the counting array using m size, and we will mark whichever is present. Okay, then we will iterate through our that counting array from end. Why from end? Because we are doing it decreasing. Correct. The array that we created previously was in increasing size, but we want it in decreasing size. So we'll start from m till 0. And whenever we get our score, we will simply put the values at the original index. How are we creating the original index? It's simply score to index I minus 1. What score to index? What was it? It was just simply our counting array. Counting array में से -1 किया. We just did the -1 from counting array. Why? Because definitely we are putting the value at I plus 1, so we have to do I minus 1 definitely. And then if the place is less than 4, we will do this, otherwise this. What's medal? Medal it, this time I've written a string instead of writing if else conditions. Definitely I haven't written this. This code is written by Leetcode, not me. Okay. So it's also a clever way to do this. Place -1, simple this. Okay. Great way. So this is the solution that you can do using counting sort. This one was something using heap sort, and this one was the very basic way to do it. Somehow you can also call this solution as using heap sort, using just array, or using like using map, just using array, creating a map just using array. Because what's this? This is just a map. We are creating a map somehow. This is a kind of map counting array. Okay. So that's for all for today. Thank you. Thanks for watching. If you like the video, please subscribe the channel. I really need it, and please do like the video. Thank you.